Hello everybody, welcome back to From Rhythm to Algorithm, where we do first principle derivation, looking for our axiom sensorality, pointing out direct empirical evidence about language, physics, mathematics, anything we can find to help us provide more logical foundation, and trying to prove and continue our theory building. So today we're going to point out, we have a couple interesting results, what seems to be some sort of a logical paradox, and some differentiations of numbers. So let's get going. First of all, again, just different bits of evidence. Sense, right? So we're looking for sensorality, but I have senses. I'm sensorial. I'm sensory, right? So we're showing that everything with animacy, everything with life, everything that has censorship or sensorality or sense, everything that relates to life starts with an S. Everything that does not relate to life starts with a C. We've demonstrated extensively the dichotomistic nature of words, how they iterate, a lot of specific examples, a lot of general principles. And so sensorality with a C, whereas when you have this dichotomy of words where you have the exact same spelling, the word emphasis is different and it changes the meaning, such as present and present, and there's a bunch of examples. I'm sure you can think of plenty on your own. And so, just another linguistic example, meaning how letters present themselves to represent those sounds, represent that logic, is you have sense, S-E-N-S-E, and then you have absence, right? If you have presence, the opposite of presence is absence. And so, but if you spell it, right, you go from sense, sensorial, to absence, where the sense in absence is spelled with a C, not an S. So again, we've showed multiple, in a lot of languages, the C and the S kind of interchangeable, what sound they represent, but why does it change from an S to a C, from sense to absence? What does inversion have to do with chirality? Again, if you go look in the mirror and you think to yourself, raise your right hand, and you look in the mirror and it looks like your left hand, why does that happen? Again, all of this geometry, the reason you have spiral, the reason your DNA is a double helix, is all emergent manifestations of chirality. And so it's just, we've covered that extensively, but that intuition is still kind of at the forefront of my mind, so I just wrote it down. But it's also evident in your brain, in your eye connection. Like if you have something in your left, coming through your left visual cortex or your left eyeball, it gets processed in the right side of your brain. Right side goes to the left side. All of those are physiological evidence of chirality. And so we've done a lot, again, trying to tease the difference, logically, the difference between basis, and bases. But again, bass, B-A-S-S, is clear to vibration. Everyone knows that. If you go to a concert and they drop the bass, you have basis, which is clearly used in a mathematical sense. But if you say this bass is that, we've kind of used up the spelling for bases. And so just really trying to figure out, well, how do we use the word base, B-A-S-E? And so another clear example we have, again, all I could think of in the last episode was baseball. But we have, I'm in my basement. And so, right, base is to down, to lower, to closer to the center of mass. But just another example of using the word base. And then we talk about how there isn't a natural or unique opposite to a center. Right, if I'm the center here, this point and this point are, equally opposite physically. And so, what is the opposite of a base? Right, you may say the opposite of a basis is a range, if you're talking mathematically. But the opposite of a base is, I don't know. And so, right, if you're centered, you're based. Again, there's some sort of logical connection between those two. But our first result is internality. So very clearly, no one can debate that if you use inter, I-N-T-E-R, as a prefix, as opposed to intra, I-N-T-R-A, the inter means between two distinct systems, and intra means within the same system. But then what is the word internal? Internality. If something is internal, very clearly and undeniably, logically, it means within a system, but literally the word is internal. So yeah, that complete word of intern but that's not. I don't really think it's a fundamental ontological word because it's an abbreviation. Coming from obviously the finance business ontology chunk, but what is internal, right? Is that a logical paradox? If it's internal, then that inter prefix is like the base whole word. Again, you could say intern is the base, but so I don't know. That just struck me as internal, meaning within a system, but it's directly using the inter prefix. So again, just something that struck me logically. That is, what do we make of that? A simple, and it's very also for like interior, right? For the interior of something, that definitely means inside, but it's inter. So what's going on there? And just a couple more examples. But another just stated empirical fact. Like people say, what is life? Well, I have a functional definition we can use. Life is young, right? Everything that is alive now today hasn't died yet. You only live once. It's almost like society would force that saying, YOLO, if it was true. Wait, oh, yeah, society did. And so, but it's very poignant that again, like no animal, plant, everything that is living by any objective measure is young. So that's what life is. But it's true. I mean, it's a very simple, very empirical thing, very visceral, but it's extremely, extremely true. So now we have some more linguistical evidence. What do we make of words like cooperate or coordinate or reestablish? And what I mean is a word that very clearly will strike you as it has a prefix, but the last letter of the prefix is the first letter of the next word or another vowel, or just some way that it makes it like kind of hard. Like, do you put a hyphen there, right? A lot of times people will hyphenate words. When do they hyphenate words, right? So these are all these first principle questions that we can ask. And again, why do people naturally italicize words? And those are all the words that are fundamentally ontological. It's when people, they italicize them. And so, but if you have coordinate, right? Coordinate, right? It's like a prefix of co and then ordinate, and then cooperate, which is, right, you might not say ordinate, you might say ordinate, but you know, it's not coordinate, maybe you might say that's not even a word at all, I don't know. But cooperate, where operate is clearly an independent word, and then co is clearly the prefix. So cooperate, is it hyphenated, is it not hyphenated, do we keep the other O, like what is exactly going on there? And why do we hyphenate it as opposed to just a clean prefix? What's going on? In the book I'm reading and about to review, the Goodbye Eastern Europe, he uses the term re-establish, right? It's very clear as to logically what you mean, but linguistically, how do we represent that consistently? So if you were bored and wondering what you should do on your Saturday night, you should too wonder the logical consistency of using hyphens with words. But it's true. Like, what is going on here in relations to the clear iteration aspects of language that we've already pointed out? And then other words like sausage or dichotomistic pairs such as sausage and a sewage. I don't even know if I'm saying that correctly. Sewage to lessen, but it uses the same letters, exactly the same amount of letters, just in a different order. So now to make our iteration function more specific in what it does, you can take two words with the exact same elementality, right? Or dimensionality in physics, but in mathematics, elementality, just any element. Any that represents an object. And so we have the Pauli exclusion principle, mass occupies space, two fermions can't occupy have the same atomic or the same quantum numbers. But so you have some sort of just inherent mass condensing is creating the space, and so you just have that where it's like an element. You just have completeness, you have discreteness. And so you can have just choosing each space as complete and then breaking it down again to the geometric linguistics. Do letters such as G or Y go below the symmetry line in the dots of I, or if you make an H, a lowercase h, and then some of the Nordic countries have that little dash through the top of it. So all of these things we can start breaking down to the accents of different languages, and how they're represented. But again, just what do we make of words that have the exact same elementality? How many letters make up the word? The same letters in a different order. Are they directly iterated? What can we say about those? Returning to some mathematics, just standard mathematics. What is a function? Functions contain elements and operators. And again, we have some boundings. Again, even if it's just intuitive or proportionalities or inverse proportions of what an element can be in relation to space, density considerations, and really putting physical bounds on mathematical ideas. And so an element is a unit. What describes a unit? Something that is unique, that has a definite size of space, and it is irreducible. Remember, we have our minimum limit that you can't break it down anymore. And so operations, we've now classified, they're either increasing or decreasing, right? Addition, multiplication, exponentiation, those are all operations that increase an element, and then division, subtraction, and then whatever the natural word for reversing exponentiation would be, rooting, returning to zero, finding the intersections, whatever. But they're all increasing or decreasing of whatever that element you're operating on is. And so we talked a little bit about how there's an implied basis between subtraction and addition, trying to really figure out a logical reason for order of operation as opposed to PEMDAS and then you read left to right or right to left. We just kind of glossed over that in third grade, and that really needs a lot of work. But you have two types of operators, they either increase or decrease. We have physical bounds for what an element can be, simply meaning an object, whether that's a set, whether that's a number, whether that's a scalar, whether that's a vector. Just a fundamental concept of a unit is an element. Hence the element, the periodic table of elements, or that stuff. That's why they use that word. And so, like I said, it's not like we're changing the word. We're showing you why the word you already use in this section of science apply to this section of science. That science is pretty much everything. Because language is literally a physical system. But and then our functions can they can increase or decrease gradually or rapidly. And so magnitude or value is the two words that I'm not sure the exact correct word. But again, if you have a vector, you have a magnitude and a direction. A scalar just has a magnitude. And now, here in a second, we're going to show that magnitude numbers are all of your cardinal numbers, and ordinal numbers are all of your ordered numbers. And what the implications for that. But then we can say, when do we use function in a sentence? Because remember, everybody speaks in fundamental ontology all of the time. It's just not specific enough to be a math proof. And so when do you use the word work? If somebody, don't forget this lecture series, forget any sort of fundamental physics, just go listen to anybody that's ever spoken the English language naturally or not naturally, and listen to when they say the word work. What are they asking? Hey man, did that work? What are they asking? Did it function, right? If you have a new approach to assemble a piece of furniture from IKEA and you can't seem to get it to put together, and your friend's like, hey man, did it work? You tried something new, did it work? Did it function? Did it operate? And so conceptually we've related work to function, work functions. That's literally what people ask. Did this thing work? Did it function? Did it move? Did it progress? Did you do work? Did the function complete? And so we've connected direct, logical, physical, mathematical, linguistical connection right there. And now to our numeric result.